Okay, so the last topic is on quadratic models, and I think we've done quite a bit on quadratics already, but we're going to try to model, we cover that up so I don't have to look at it all, we're trying to model real-world situations using quadratic functions. We've done real-world situations with lines. I give you 2 points, you find the line that fits those. Today I'm going to give you 3 points, and if you have 3 points, it might look like a parabola. In fact, if I give you 3 points, there's always a parabola that will fit those 3 points, always. 2 points, there's always a line that fits them exactly. 3 points, there's always a parabola that fits them exactly. That's going to be our job, is to find that. When I say 3 things, 3 points, that means we're going to have 3 unknowns. That makes the problem a little harder than having 2 unknowns. So when I say 3 unknowns, my unknowns will be A, B, and C. Because I'm going to be putting it into a quadratic function, ax squared plus bx plus c. I'm going to have to find 3 unknowns. When we did a line, there were 2 unknowns, the slope and the y-intercept perhaps. But now there'll be 3. So the example I have, in the very first one I pick, I'm going to do about 3 of these. The very first one I pick, I'm going to tell you right now, the numbers don't work out well because it's actually a real-world problem. And the real-world problem is this. When you guys go to college and you guys get your undergraduate degree, some of you are going to go to graduate school. Probably lots of you will go to graduate school. And some of you guys are going to study, you're going to get into science. And this deals with a parakeet problem, a research problem. Here's what they found. When a parakeet flies at 12 miles per hour. I don't know how they discovered these things. But if a parakeet flies at 12 miles per hour, it burns 152 calories. If the parakeet flies at 22 miles per hour, it only burns 105 calories. And if the parakeet flies at 30 miles per hour, now all of a sudden it's burning 165 calories. What I would like to do is find how many calories the parakeet would be burning if it flies at 26 miles per hour. Before I do this one all by hand, I'm going to jump. Does anybody have all the numbers written down? Because I'm going to put this into my calculator, and I'm going to show you something that I'm sure none of you have done before. And it's really not my intent, but I'm not how I want you to do it, but I want to show you what the answers are using technology, and then we're going to go back and we're going to do it the hard way, old-fashioned way, I suppose. We have the data? Okay, let's switch here. You don't have to do this. If you want, you can. I'm going to plug these in to stat edit. So in list 1, what were the miles per hour? 12, 22, and 30. And what were the corresponding calories burned? 152. I'm putting that in list 2. 15 and 165. All right. I'm going to plot these. I already have my plot turned on, and I want it to be a scatter plot, and I'm looking in list 1, list 2. And I'm going to say zoom stat so I don't have to fix the window. The calculator will do the window for me. There are my 3 points that it plotted. I hope that it looks to you that that does not appear to be a line, right? Let's find the parabola that fits that using technology. So we're going to go to Stat, Calc. And if you cruise down a little ways, I think I showed you linear regression. We're going to do quadratic regression, which is number 5. This is a process called regression analysis. We'll learn a lot about this more towards the end of the year. But right now I'm just giving you the skinny on it. So I'm going to look in list 1, list 2. I'm going to tell the calculator to look in list 1, comma, list 2. That's above the 1 and the 2. Comma. I would like to store my answer. In the y equals. So you go to vars, you go to y vars, and then you can pick function, and you can pick any of them. I'm just going to choose to put this one in y1. I could put it in any of them. Now it's in Y1. When I hit enter, the calculator does all the work for me. And it says the A is about 0.68, the B is negative 27.74, and the C is 387.333. What I would like you to do is write those numbers down for me because I want to compare it to what we're going to get when we do it longhand. Before I do that, I would also like, before I do it longhand, you guys get those numbers, go with 3 decimal places. I'm not going to go further than that. Because this is a real world problem, it doesn't just work out to be like 5 and negative 2 and 6. The beginning problems on our assignment will work out like that, real nice, but this one doesn't work out real nice. Now it stored that into my y equals because I told it to. When I graph, notice my parabola fits those 3 points perfectly. Not about, but perfectly. I'd like you to write down one more number, and that is I'm going to calculate the value when x is 26. So it tells me that the parakeet is burning 124 calories when it's flying at 26 miles per hour.
Does this mean that it's going to fly at that speed for an hour, or is it just something that running it once it reaches that speed?
You know what? There definitely has some limitations, right? The parakeet isn't just going to keep flying faster and faster and faster until it just disintegrates. Okay. What we would be interested in this problem is where should the parakeet fly over a long period of time? What would be the logical move? If you could talk to this parakeet, where would you tell them to fly?
Where you get fastest for your gain.
Right there, huh? The minimum number of calories burned, if they're going to fly for 8 hours, it would make a lot more sense to fly at this speed than even here, right? And maybe what happens is the parakeet's got to work really hard to get up to that speed, so they're burning more calories. Once they get up to that speed, their calories burned are low. Now if they try to speed up, they're going to burn more. So that's called a minimum, right? That's a vertex. If I give you this equation, can you find the vertex of that? Opposite of b over 2a? I hope you could. Right? Opposite of b over 2a, plug that back in. You also can use technology to find the minimum. So if I say calculate, which is above the trace key, calculate the minimum, you got to move your little spider to the one side of the minimum and then move it over. If you're too impatient like I am, you can just type in a value, but I'll just move it. And then you hold it down, you hit the enter key to lock it down, and you'll see that little arrow right up there telling me that I've locked it down on that side. Get the spider on the other side of the lowest point, so I'm past it now. Hit enter, and you hit enter again. And now the calculator is going to check all the values between those 2 points. And it says this parakeet should fly at 20.46 miles per hour, and it would burn 103.41 calories as the minimum. Okay? Now, that wasn't the intent of how I want you to do that, but I wanted to show you what's happening. It looks parabolic, looks quadratic, and we found that equation. So let's jump back and let's do this one without technology. You have all the numbers written down so we can compare our answers. We'll need our calculators, but not to do all of that stuff. So here's what we're going to do. We're going to plug in this data. So I have 152 will equal a times 12 squared plus 12 times x plus c. Whoops, screwed that up. Sorry about that. Plus, I'm replacing the x with 12. So that would be 12 times b plus c. Now I'm going to go to the next piece, which is this one. I'm going to have 105 equals a times 22 squared plus 22b plus c. And the third one would say 165 will equal a times 30 squared plus 30b plus c. I have a system of equations. I have 3 equations. And you have to have 3 equations because there's 3 things you don't know. 3 unknowns. All right, so I'm going to number these 1, 2, and 3 for me to talk about how I'm going to do this. I'm sure you've done this before, but let's go through the steps on doing this. It's kind of a lot of work. Unless you know matrices, then it could go pretty fast, but I'm not going to use matrices to solve it. I'm going to do it like you would do it in algebra. Algebra 1, in fact. I'm going to take equation 2, and I'm going to subtract equation 1 from it. So I'm gonna do this. I'm gonna make a new equation. I'm just gonna call it 3. How I get it is 2 minus 1. If you do 2 minus 1, I'm gonna need a little help now. 2 minus 1. What's 105 minus 152? Negative 47. The reason I'm doing it is because I'm going to eliminate my C's. I'm going to eliminate C. I need help with this. What's 22 squared minus 12 squared? 12 squared is 144. 22 squared minus 144. 340, thank you. So I have 340A, and 22B minus 12B is 10B. I'm going to make another equation. I'm just going to call it equation 4. And how I get it is I'm going to take equation 3 and I'm going to subtract 2. Again, I'm going to eliminate C's. I'm going from 3 unknowns, I'm going to go to 2 unknowns. That's my goal, from 3 unknowns to 2 unknowns. So if I take 3 and subtract 2, I have 165 minus 105, which would be 60. Equals, I need help, what's 900 minus 22 squared?
416.
How much?
416.
Thank you. 416A, and 30 minus 22 is 8B. So now I have a new set of system of equations. I have 2 unknowns, I have 2 equations. Give me a thumbs up if you've done this before. Sideways if we don't remember. No, down if you've never done it before. Thanks. All right. Go to work. So far, so good. You understand what I'm doing? I eliminated C. Pretend, I'm assuming you've never done this before. We eliminated a letter. So we went from 3 unknowns to 2 unknowns. So now we have A and B that we don't know. I use elimination. Now I have 2 equations. I would get rid of the B now. So now I'm going to get rid of the B and I'm going to solve for A. How would I get rid of the B? So you look at these 2 equations, and what would be the most logical to get to? 10 and 8. 80 would be very logical. What would be easier, though? 40. They would both work. But I'm going to pick 40 because the number is smaller. I'll have smaller numbers to work for. So I'm going to eliminate the B. So I need to multiply this one by 4 and this one by negative 5. You have done elimination before, I know that. So I'm going to eliminate the B's. I'm going to need a little bit of help because I don't know what 47 times 4 is. I know it's around 200.
188.
Negative 188 equals, I need help here too. What's 340 times 4? I know it's around 1300. 1360. And I know that that's 40B. Now, I should have asked, why did I pick a negative 5 here instead of a positive 5? Yeah, because everybody I've ever taught in my history of my life of 22 years is kids can't subtract, so we always add. So I make 1 positive and 1 negative, that we don't make any mistakes. So I need a little help. Negative 5 times 60, I think I can handle that one on my own. Negative 300, but I need help here. 416 times negative 5. Around 2,000? Negative 2,080. And this would be minus 40B. This is good because that adds to 0. I need more help. Maybe not. Negative 488, I can do that one in my head, but this one I want help. Negative 2,080, you told me? Add 1,360 to that. And how much do we get in front of the A? Negative 720. Does anybody agree? Awesome. So A equals, help me out. Give it to me as a decimal. Because this one doesn't work out nice. You're probably saying, why don't we start with one that worked out nice? I don't know. Besides, how much? 0.6778 maybe. How did that compare to what the technology gave us? Same. Good. If it's wrong, then I got to go back and I feel stupid. But it's good. It's the same. Now, there's three things we didn't know, A, B, and C. You found one of them. What's the next step, do you think? Find B. Where are we going to find B? I would go to equation 3 or 4. One of these two right here. Which one? Doesn't matter. So pick the easiest one. Which one is the easiest? Doesn't matter, I suppose, does it? I would say the first one because the numbers are smaller, but then I might say the second one because it starts out with a positive number. I don't know which one is easiest. We have a calculator, so it doesn't really matter. So I would use the first one, so I'll have negative 47 equals 340 times A. Now, you could store this in your calculator if you want, because all of a sudden we're going to use a rounded answer to get another answer, so we're going to develop some error in our problem. I'm assuming your science teachers have talked to you about that. But when you use rounded answers to get more answers, you get more and more error.
Well, you could try to put in something like 2/3.
Can I show you what you would do with a calculator? Because evidently we don't have a real great background on calculators either. Here's something you could do on your calculator. I need help though. What was that number that we just had to get that decimal? What was the fraction? What did you divide?
Negative 488 divided by negative 720.
So you take that and you store it. You guys see the store button? STO. You store it, and I'm going to store it as A. Do you see the A right below the alpha key? Store it as A, and now you have it, and you don't have to use approximation. You can use the exact answer. So now I got to go back because I don't remember what that number was. A is right below the alpha key, right above the math key. You hit alpha, math. So now I have stored it. So now if I go over here, you guys, here's what I could do. 340 times A. 340 times A. There it is, and I didn't have to approximate. 340A. I need to take negative 47 minus that, so I'd say negative 47, and then I'm going to subtract my answer, and I'm going to divide that by 10. And how does that compare to what we had on the board for B? And I guess I could just pull this back up here and look at this. It looks like it's exactly the same. There's your B. I need help. What was it? Negative 7.4. 7.4? Okay. So there's my B. How do you think you're going to get your C? Because you're almost done. Go back to the original. Which one is the easiest? I'd go right here. There's my easiest. So let's go ahead and write this down. 152 equals 144 times A. I'm just going to use the approximation this time. Plus 12 times B plus C. So use your technology, use your calculator, multiply, add, multiply, move it over, and tell me what C equals. Let's see if I can pull this up and do it at the same time. Not very well. So I'd have 152 minus 144 times 0.6778 plus 12 times negative 27.74. Is that what I was supposed to get? I got negative 278. I probably typed something in wrong.
I got 387.333 repeating.
And I should have gotten 387.333 repeating.
Awesome, I was right.
You should get 387.33 repeating. Okay?
That makes me
Now.
happy.
There's your A, B, and C. Let's back up now. And let's do something really easy. Exact same steps, but let's do a book problem that works out nice. So not a real world problem like the parakeets. So let's go through the steps. If you have questions, please ask. The first one, and this is actually number 1 from your homework. Here's what they give you. They give you f at 0 is 5, f at 1 is 10, and f at 2 is 19. We need to put it in the form f of x equals ax squared plus bx plus c. We need to find the a, b, and c. So let's write down what we know. This one, by the way, just so you know, that's an ordered pair 0, 5. This is an ordered pair 1, 10. This is an ordered pair 2, 19. So when I substitute in the data, I end up with this. 5 equals a times 0 squared plus b times 0 plus c. Why is that one awesome to have? I mean, that's like a major smiley face. That's a major smiley face right there when they give you this.
The media center is now open, and I also need 10th graders with the last name A through C to report to the student comments area for vision and hearing screening. That's 10th graders with the last names A through C to the student comments.
You already know one of the 3 points of the values. You know one of the 3. You know that C is 5. Also, you knew that from yesterday because C is the y-intercept. What does that give you right there? The y-intercept. So no surprise. You already know one of the 3. Now it's going to be a lot less work than the last problem. You already know that C is 5. So using the next point, using this point right here, I would have 10 equals a times 1 squared plus b times 1 plus 5. I'm not going to say plus c because I know that c is 5. Using the third point, I have 19 equals a times 2 squared plus b times 2 plus 5. So here are my 2 equations that I need to solve. If I simplify that, it would look like this. A plus b equals 5. Move the 5 to the other side, and then I twisted them around. The second equation would say 4 times a plus 2b equals 14. There's my system. I would eliminate the b. I would eliminate the b by multiplying this one by -2 and this one by 1. Then I would eliminate the b. So if I multiply the top one by -2, I have -2a minus 2b equals a -10. The bottom one I multiplied by 1, so it stays exactly the same. When you add those, your b's are eliminated. You have 2a equals 4, so a equals 2. Now you're 2/3 done. And finally, we need to find out the b. I would go right back to this one because it has the easiest numbers to work with. 2 plus b equals 5, so b equals 3. So a is 2, b is 3, c is 5. If you write it in function notation, it would look like this. F of x equals 2x squared plus 3x plus 5. There's my function. If I take every single point and I plug it into this, if I plug in this, this, and this, they would all be true because they're all solutions. So that one, that's kind of the way they normally are. They're not like the parakeets where they work out bad. They work out nice usually when they're book problems. Let's do one more. This is number 2 from our homework. I would have picked 3 because I'm assigning odds, But number 3 is exactly like number 1, so I thought we should do one that maybe doesn't have this. Whenever it has this, man, that's awesome. But number 2 didn't have it, so that's why I picked it to add it to your notes. I might have to scroll down a little bit. We'll see. The number's right here. I'm not going to put them in ordered pair form. I'm just going to write the equations. Again, our goal is to find A, B, and C. So what I would have is 10.5 equals A times 1 squared plus B times 1 plus C. 1 is pretty nice to have. The next one is 13 equals A times 2 squared plus B times 2 plus C. And the last one is 32.5 would equal 5, A times 5 squared plus B times 5 plus C. So there's my system of equations. 3 equations, 3 unknowns. I'll call this equation 1, equation 2, and equation 3. Just like we did with the parakeets, except the numbers will work out better. I'm going to take equation 2 and subtract equation 1. The reason I'm going to do that, and usually I say I shouldn't subtract, but we're in pre-calculus, so I think you guys can handle subtract. The reason I'm going to do that is because I'm going to eliminate the C's when I do that. If you wanted to multiply one of them by -1 and then add, that's the same thing, but we're going to take a chance that you can do this. 2 and subtract 1 would give me 2.5. Let's switch colors here. 2.5, that's 4 minus 1, so that's 3A plus B. I eliminated the C. The next thing I would like to do is I'd like to take 3 and subtract 2. And you can follow this method for all of them. It doesn't have to go this way, but this works. 3 and subtract 2, I need help. What's 32.5 minus 13? 19.5 equals 5 squared would be 25 minus 4, so that's 21A, and that's 3B. So now I have a new set of system of equations. We can eliminate one of them. What would we eliminate? I think I ought to go with the B's. Could go with A's as well. But let's go with B. So I'm going to eliminate the B. So I'm going to multiply this one right here by -3. And this one I'm going to keep exactly the same. So here's my shorthand notation. I'm going to put it right underneath it. I need help. What's -3 times 2.5? -7.5? So this is -7.5. This is -9A. This is -3B. If I do that and look at this one and this one, my B's will be eliminated. What do I have? 12 equals 12A. Man, this is definitely a book problem. Because what does that say? A equals 1. That's beautiful. We're going to take that and plug back in. Where are we going to plug it in? Because my next step I want is B. So where am I going to plug it in? I'd pick this equation right here. In your head, can you do it? What's 3 times 1? 3. Move the 3 to the other side. 2.5 minus 3. -0.5 or 1/2. Now we have to find C. How are we going to find C? I would plug in, if I were going to pick, I'd pick that one. Because the numbers are the smallest. So we're going to plug in those numbers. I wrote that in a bad spot, didn't I? I wrote that in a bad spot. I'm too close. Where should I plug it in? Yeah, I'm okay right there, aren't I? For A and B? Sorry. A little brain freeze a second. If I plug it in right there, so we're going to replace this with 1. you're going to replace this with negative 1/2. So this is 1, this is negative 1/2, that's a half. Subtract a half, C equals 10. There's your 3 unknowns. So your equation for this one would be f of x equals 1x squared minus 1/2 x plus 10. That's number 2. They require some work when you have to do those. Sometimes they work out really easy. Not many are going to be like the parakeet problem, though. Solving. Hopefully now you know how to solve a system of equations with 3 unknowns. I won't make you do 4. If I made you do 4, we'd use matrices. Have you used matrices before? This is where I need to bite my tongue. Okay. Here's what we're going to work on. 1 through 15 odd, 6 and 8. I need to help you do 1 or 2 of these, though. I don't need to do more like that. You need to practice some of them now. You've watched me do them. Hopefully you followed along. So I don't want to do more like that, but I want to do a physics problem. How many of you are in physics? Good. If you're in physics, this will make more sense to you. If you're not in physics, don't worry about it. But if you're in physics, the two go together. Let's do, so you have that written down? We just did number 1. We did 2 and 2. 1 is like 3 and 4 is like 2. Then there'll be some word problems where you're going to have to write equations. But then there are some that deal with this. This is the formula that they give you from physics. So I would like to do 1 or 2 of the problems. This assignment isn't very long, is it? It's like 8 or 9 or something like that problems. And we've already done 1. So I'd like to do another one. The intent is that you're supposed to read this, but I would like to just make a little comment. And let's do number, I don't know, let's do number 11. So I'm on page 47. I might want to do 12 or 14 if we have time with you just for review, but not right now. I didn't assign them, but they're good problems, and we usually do them. Number 11. So here's a formula from physics that says the height of an object at any time t is negative 4.9 t squared, t is time in seconds, times your initial velocity. This v sub 0 is my initial velocity.
I've seen it.
And my h sub 0 is my initial height. This formula is when we're dealing with velocity in meters per second. So of course my height would need to be in meters. If we were dealing with feet per second, the negative 4.9 would become a negative 16. Where does that come from? You've learned about gravity, right? G if you're in physics or physical science or chemistry, we usually use a G. What is the effect of gravity? What if I drop this pen and that calculus book? Which one hits the ground first? This calculus book is really, really heavy. This pen isn't very heavy. Which one hits the ground first? Can hardly hold it up. Same time. So you have been listening in science class. That's good. Doesn't matter how heavy they are. Assuming there's no air resistance. Speeds up, things fall at a rate of 9.8 meters per second. So they speed up as they drop. 9.8 meters per second. 4.9 is half of 9.8, by the way. But we're not here to talk about that right now. We're just here to apply this formula. So on number 11, they ask you, a stone is thrown with an upward velocity of 14 meters per second from a cliff 30 meters high. So the reason I love these is you guys get to see my artistic skills. So this thing is thrown up like this. If you draw a picture, it's going to make these problems much easier, in my opinion.
If you help me remind if you would tell me what exactly is going on.
We're throwing a water balloon. because we want to hit the buffalo that's standing down there.
Awesome.
Kind of like being in downtown Minneapolis, standing on top of a hotel and trying to hit a bus. If you're bored. With a water balloon. Not that I would ever do that. All right, hey, I need help. What's my initial velocity? What's my initial velocity? 14. What's my initial height? So my initial velocity is 14 meters per second. My initial height is 30 meters. So that means I'm throwing this thing. We're assuming that the height of the water balloon is 30 meters, even though it's at the cliff, because I'm standing there and I'm 5 feet tall. Whatever. So my formula is this. H at t is negative 4.9 t squared plus 14t plus 30. There's your formula. Is that what it asks for in A? Find its height above the ground t seconds later. There's the height. There's the height t seconds later. The height in terms of time. That's the height in terms of time. There it is. That's A. B. When will the stone reach its highest elevation? What's that called? The maximum, which is the vertex. You don't need technology. We could plot this and graph it and look for the maximum, but you want to know, when does the water balloon reach its highest point? And that is the vertex. How do I find it? There's a simple formula you have to know, and that is time equals the opposite of b over 2a. That's when it will always reach its highest or lowest point. That's the axis of symmetry. So we plug in here and we have negative 14 over 2 times negative 4.9. And what does that say? I need help. It's positive, thank goodness. If it's negative, I know I have a problem. 14 divided by 34. Ooh, seems too much. I think it's like 1 point something. 1.428. And that's seconds. Make sure you use parentheses when you divide. Did that tell me the highest point the water balloon was? No, it tells me when it's at its highest point. The time right here is 1.428 seconds. What's the highest point? How do I find the highest point? I want to know the height evaluated at 1.428 seconds. How much is that? So you take this and you plug it back into your formula. You replace the t and the t. I'll let you guys plug that in for me. Oh, actually, I'm sorry. It didn't ask for that, but we're still going to find it because we're overachievers. Yes. It asked for when did it reach its highest point. I want to know what is the highest point, not on the assignment. Who's got it? How much? Say it with confidence. You're a 39, I heard a 43, and I heard a 62. $39.994. Levi?
I got
40 even? You rounded a little bit maybe? Maybe not. You had negative, or you had 39.99? All right, good enough. So 39.99, about 40 meters is how high it is. What does the last part of the question ask? When does the water balloon hit the buffalo? I want to know this. What's another name for this right here, you guys? X-intercept. It's a root. Can you use the quadratic formula to find the root? You're going to get 2 of them. You're going to get another one back here. Does that one make sense?
No.
No, so make sure you take the one that makes sense.